Hello everyone, welcome back to the next session of multimedia system. We will be continuing with our discussion with respect to the topic data compression. In the previous session, we had discussed about the arithmetic coding, the different modes of coding, the basic technologies, and then we had jumped into an interesting topic called Jpeg, in which we had seen the importance of Jpeg format, why it has become so popular with respect of still image formatting, and why it was called so important with respect to the digital images also. And we have seen how the Jpeg was evolved, what was the technique that is constitute with respect to the Jpeg with respect to compression and decompression, and it was the DCT, that is discrete cosine transformation. And we had seen about the modes of Jpeg compression. The four modes were also discussed. Now let us look into the next topic, that is the how does Jpeg compression works. This is one of the important topic, so I'll make it as an asterisk. So it needs to be considered as an importance one. Now let us look into the various steps that are involved with respect to the working principle of a JPEG. So we know that when we wanted to compress any of the image, first and the foremost thing is the image, the raw image has to be converted into digital form. So first is a digitization of image. So during the process of digitization of image, here with respect to JPEG, we need to perform the operation called splitting. So that would be the first step. So what we do in the splitting? In the splitting, the image is split into 8 cross 8 non-overlapping blocks. Means the given image has to be split into 8 cross 8 non-overlapping blocks, means it should constitute of 8 into 8, that is 64 units. So means that image should consist of 64 units. Let us look into it. Now consider this as an image. This image consists of a letter called A. Now if you want to convert or use the JPEG compression over this image, we need to digitize and split this image into 8 cross 8. Means we need to have a total of 64 units. So I will be splitting it. Now this has become 4. Now I will be splitting it again. Now you can clearly see we have 8 columns. Again we need to split it to have 8 rows. Now we have 4 rows. So again I will split it in order to have 8 cross 8 matrix. Look at this. Now our letter A is here. I'll highlight it here. Okay. So here we have 8 and here we have 8, and the total of 8 into 8, 64 units are present. So this is said to be the first case. So first is we are about to split the image into 8 cross 8 non-overlapping blocks. Second one is, that is color space transformation. We call this as color space transformation. So what we do here, usually when we consider any of the image, it would be in the form of RGB, that is red, green and blue. Now we need to convert this RGB format into YUV or YIQ format. We have already discussed about YUV and YIQ. So here it is red, green and blue. Now this format of RGB of an image is now transformed, or we need to convert into YUV or YIQ format. So what is this? Where Y stands for luminance and UV stands for chrominance. Here also Y stands for luminance, whereas IQ stands for chrominance. We can use either one of the format. So luminance, what is luminance? As the name suggests, luminance is the light factor, the parameter that is associated with the light or a brightness of an image is called the luminance factor. And UV or IQ is said to be the chrominance factor, means the color associated with the image is said to be the chrominance factor. So now the two steps are finished. Now what is the third step? Third step is DCT. Now what we do here is we apply the DCT transformation on each of the 8x8 block. Means we apply the discrete cosine transformation to each of the blocks here. To every block we apply this transformation. So what we do after that? After that we go with quantization. Quantization, here we quantize the DCT coefficients, because we have applied the DCT there, and what we get? We get the DCT coefficients. Now in the stage 4 we quantize the DCT coefficients. Next is the fifth stage. Fifth stage is a very interesting one. Why it is interesting is, here we do up a activity called serialization. What is serialization? It is a zigzag scanning pattern. So you might be very much aware, when we do talk about the Jpeg, we do a scanning pattern in a zigzag form. So that's why this Jpeg is a Jpeg compression is one of the interesting, because of the scanning pattern we use, that is a zigzag. So why do we do a zigzag pattern here? To exploit the redundancy, we take up this part, that is step, that is zigzag scanning. And the sixth one is vectorization or vectorizing. What happens here? Here we do DPCM, that is differential pulse code modulation on DC components. Now we have quantized with respect to DCT coefficients. When we scan, we remove the redundancy. Okay, we overcome the redundancy. Now in a vectorization, we apply DPCM, that is differential pulse code modulation on the DC components. And finally, the last stage, we apply the algorithm, means we apply coding. Here we apply either run length or the Huffman coding for this process. So these are said to be the different steps with respect to working or a compression of a JPEG image. So this is purely for an image, since JPEG mainly supports still images. Even in a JPEG we have motion images, we call it as a motion JPEG, but here we are mainly talking about the still images of a JPEG. I'll recall this before going into the practical demonstration. Look at this. The first step, we are splitting it. So what we are splitting? We are taking the raw images and converting into digitization form, where the image is split into 8 cross 8 non-overlapping blocks. Means there are total of, you can look into that, 64 units. So this is the first step. In the second step, we do a color space transformation. During the color space transformation, the natural raw image of RGB is totally transformed into YUV format or YIQ format, whichever is needed for the convenience, where we concentrate on chrominance and luminance factor here. Then we apply the DCT. So we apply DCT on each 8 cross 8 blocks. And the fourth step is quantization. We quantize the DCT coefficient. The exact loss of information happens here during the quantization. What do you mean by quantization? You know, a similar valued data in a particular stream are grouped together. Means when we group, we neglect a non-similar pattern to some extent. So where the loss of information is happening. So because JPEG is a lossy compression, means there is a bit of loss of information. That exactly happens in this step, that is 4, quantization. In the fifth stage, we do up a scanning process in a zigzag pattern. So we call it as serialization. Why do we do that zigzag pattern of scanning is totally to exploit the redundancy here. And the sixth one is vectoring. We apply the DPCM, the differential pulse code modulation principle, on the DC components what we have obtained from a matrix. And finally, we apply the coding. So whatever the coding we wish, either run length or Huffman coding is employed on the block. So this is the working principle of the JPEG. Let us take an example and look into it. So what we do initially? So initially we need to split the image into 8 cross 8 like this, non-overlapping blocks. So when we split an image into 8 cross 8 matrix of non-overlapping blocks, each block has its own value. So each block has its own value, means each block is based on the contents of an image, it has its own value. Let us write a matrix like this. I'll start from here. So 52, 55, 61, 66, 70, 61, 64 and 73. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 columns. In the similar way, we are supposed to have 8 rows. So here it goes like this: 63, 62, 67, 69, 85, 87, 63. Now this is a 8 cross 8 matrix. Okay, even I am supposed to fill all this data will be there. Just for the demonstration purpose, I am taking one row and one column, that's it. I am not considering all other things, but in a practicality every data would be filled up everywhere, here, here, here. So you are supposed to consider it is a totally filled matrix with respect to 8 cross 8. Now here when we look into this kind of matrix, the range of a pixel intensities are now from 0 to 255. Means the range of intensities of the pixel here is ranging from 0 to 255. You can see here it would be either from 0 to 255. So any range would be there. Even there might be the possibility of repeated values. Now the next thing what we do is here is we need to change the range from minus 128 to change the range from minus 128 to 127. So this is the next what we are supposed to do. Why do we need to change it? So the reason is just to compress and reduce the size of the file. Okay, we want our range to be in a limited fashion. Even the size of the file needs to be reduced. So how to do this? We would be subtracting 128 from each pixel. Okay, means whatever the value is there, we would be subtracting each value, okay, from this kind of value. Means 52 minus 128, 55 minus 128, 61 minus 128. Now what we get? So most of the time we get the negative values here. So how do we do it? We'll do it like this. I'll rub this and demonstrate with the same values. When we subtract this, I'll just write one line. We get minus 76, minus 73, minus 67, minus 58, minus 67, minus 64, minus 55, and here it would be minus 65, minus 66, minus 65, and so on. It goes on like this. Now what happened? The total range we have changed from 0 to 255 range to minus 128 to 127 range. Now what are the next step? Next we need to compute this matrix by applying the formula that is been provided. What is that formula that is been provided is, the formula goes like this. That is a new matrix of Vu is equal to 1 by 4 the C of U, the C of V by the summation of x to the 0 to n and the summation of y to the 0 to 7, that is n minus 1 means 8 minus 1 it's 7 here, to the y of cos 2x plus 1 by 16, that is u into pi, because we are taking two matrices, cos of 2y plus 1, then v of pi divided by 16. So this is the standard formula that is been provided. So now we'll apply this formula for the matrix what we have converted from the 0 to 256 range to minus 128 to 127. Where what is this? C of uv comma C of v is equal to 1 by square root of 2 for u or v is equal to 0 in this case. Otherwise the C of u comma C of v is equal to 1. This should be considered. Now what happens here? We are substituting this into this equation into the obtained matrix. So when we apply this formula to that matrix, the matrix gets changed. What is that resultant matrix? We store that resultant matrix as S of VU, S of VU will be represented as that S of VU. Then there is a standard matrix that is used for computing the Jpeg compression, which is given by the matrix called Luninance Matrix. So what is that Luninance Matrix? Luninance matrix is also an 8 cross 8 matrix where there is a standard value given, standard value provided, and that value is called Luninance 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 matrix. Now we have this matrix as Q of VU. Now we have two matrices. One is S of VU, that is what we have obtained, that is after the conversion from 0 to 255 to minus 128 to 127 range, that is called S of VU, and second one is Luninance matrix. So Luninance matrix, what does it look? How does it look? You can see it here. So it is a standard matrix. Now we would apply the formula. What is that formula? That formula is S of, that is small s of Q of VU is equal to round of capital S of VU by capital S of capital Q of VU. Means we are dividing it and rounding of this. So what is this process exactly? This process is exactly the quantization. Here the quantization process is happening. So when we quantize, the resultant matrix look in a different way. So we have, when we apply this formula of quantization, we get the matrix like this. Minus 26, minus 3, minus 6, minus 4 and so on, minus 12, minus 4, 8, so on, and later here the values would be 0. So rest would be 0. Now you can see only this portion of the matrix has some value. The remaining portion are totally constituting of zeros, almost like this region. So what is the inference of this? Here the quantization is happening. When we talk about the quantization, it is, you know, that removing or combining the likely or similar kind of values are grouped together and excluding the other things. So quantization happens, and after the quantization, what are we supposed to do? The serialization, the scanning process. So now we need to scan this matrix. So we know that we have a matrix that is 8 cross 8. Eight columns are ready. 4 columns are ready. I need to have 8 columns. So here we have 8 and here we have 8. Now the recently what I rubbed here, the matrices would look like this. So if you represent those values in the matrix, it would be like this. So this is a 8 cross 8 matrix. Now what are we supposed to do? We saw in that step the zigzag pattern of scanning. So here this is the zigzag movement is very important in the JPEG. Why? We discussed it to explicitly avoid the redundancy. And how does this zigzag pattern of scanning happens? Look at this. So here like this, comes here, goes here like this, come here, then go here, travel here, go here, and then come here. So here, then go here, come back, and next it would come here. See here the movement. Look at this. This is called the zigzag movement. I will draw it again for a better understanding over the line. Look at this. Means the each pixel in the nodes are being visited. See, from here it goes like this. Next, come here. Like this. So in this way, so all the nodes of 8x8 matrix has been visited. So what is the next? Next we need to transform this 8x matrix into the desired form. Either it would be (64:1) matrix, 64 columns, 64 rows, 1 column, or one row into a 64 columns. So here therefore now the total compressed data is written here. This compressed data is written into one dimensional things. So the overall two dimensional data is been compressed and represented in one dimensional. That would represent the end of the process. This is how the working principle of JPEG works. So this is what I had wished to explain. So this question is very important in the view of examination. So usually you might have seen in many of the question paper they have been asked, what is JPEG? Okay, what kind of lossy technique is associated with JPEG? Obviously a lossy compression, because during the process of quantization we are losing a bit or minute amount of information, and once we compressed image is done, if you regenerate the image, the original image totally differs from the obtained image. So it is a lossy technique. So even in the examination they ask it, explain the working principle of JPEG with the various steps. So in those cases, what the different steps what I had mentioned here, you are supposed to write those steps, explain it clearly, and also with the help of the diagram you would be able to express or brief the various stages of the compression with respect to JPEG image. These are the things I had wished to explain in this session. Thank you very much.